You're building an AI agent and immediately hit a wall. Do you wire it using direct APIs, the Model Context Protocol, or agent-to-agent communication? Trying to figure out which standard wins is a trap. Force one protocol to handle every connection, and your system will snap under the tension. These protocols are not competing. Asking whether MCP beats A2A is like asking if a power outlet beats a phone call. They handle entirely different jobs. To know which one to use, you only need to evaluate two things about the connection you want to make: the direction of the data and the required visibility. Direction dictates whether your agent needs to reach vertically down into a database or horizontally across to another agent. Visibility dictates whether you require total transparency into how a task is done, or if you must pass work to a secure, opaque black box. By mapping out those two vectors, you can pinpoint the exact integration layer your project needs right now. Choosing a standard based on industry hype rather than strict architectural boundaries leaves you with a mountain of technical debt or a massively over-engineered prototype. Let's start with the baseline of direct API integration. You hand your large language model the raw documentation for a service, and it figures out what code it needs to write. But the model cannot actually execute that code. You have to build software outside the model that holds the authentication keys, handles the network requests, and manages the error retries. That software wrapper is your execution layer. This grid shows the scaling problem. Build one application talking to 10 services, like Slack or Jira, and you write 10 distinct execution layers. Add a second app next year, you write 10 new redundant integrations. You now maintain 20 separate piles of code. The Model Context Protocol, or MCP, eliminates that compounding debt. It acts as a standardized, universal execution layer. Looking at this stack, MCP separates integration. You place a client inside your app and a server in front of the API. The client runs discovery, retrieving a menu of actions. The agent selects an action. The command travels down, and the server executes the final step. MCP does not replace your APIs. It wraps them in a common language, meaning any new AI app you build can reuse those exact same servers without writing fresh integration code. This gives MCP its defining visibility trait: transparent capability injection. The agent sees every single tool and resource it connects to, pulling them straight into its own context. That total transparency is highly effective when an agent is querying your internal company databases or reading your local files. The initial effort of building an MCP server pays off the moment your second or third application connects to your tools without requiring any manual coding or new credentials. The math changes entirely the moment your internal agent needs to buy software licenses from a third-party merchant agent. You have reached a trust boundary. This is the hard perimeter separating your controlled internal systems from uncontrolled external networks. Using MCP across a trust boundary is a severe security failure. Because MCP relies on total transparency, you would be handing an external entity full visibility into your internal tools. To safely delegate work horizontally across these boundaries, you use the agent-to-agent protocol, or A2A. A2A operates on the principle of opaque task delegation. Agents hand work to each other without exposing their internal thoughts or specific tool implementations. This side-by-side comparison shows the structural difference. MCP plugs tools directly into an agent. A2A treats agents as independent black boxes, passing a sealed envelope. To advertise capabilities, it publishes an agent card, a formatted resume detailing its name, skills, and endpoints. The object model is precise. The client agent sends a task inside an envelope, and the remote agent processes it until it can return an artifact as the finished deliverable. Because A2A crosses company lines, the standard is flexible on how the data travels. It supports JSON RPC, gRPC, or standard REST. In practice, your shopping agent uses A2A to request a custom offer from a merchant agent. They negotiate the pricing back and forth, completely blind to the internal logic or data of the other side. A2A strips away internal visibility entirely. It leverages that opacity to guarantee the security required to execute cross-company collaboration. These protocols do not replace each other. They stack together into a single unified machine. APIs do the actual work. MCP wires your agent down to its tools,
and A2A wires your agent across to the rest of the network. This matrix maps when to deploy each layer. Solo developers building MVPs rely on raw APIs to maximize speed. Engineering leads scaling multiple apps implement MCP to standardize internal tools. Finally, architecting a multi-agent platform requires A2A to securely negotiate with external vendors. Do not force these tools into the wrong roles. If you adopt A2A internally just to fetch basic data, the black box opacity will severely hinder your debugging process. Conversely, if you expose an MCP server directly to an external, untrusted agent, you risk broadcasting sensitive internal data. In a mature production environment, you will rely on all three of these protocols firing simultaneously. The most efficient AI stacks are built by identifying the specific trust boundary involved in a task and selecting the protocol designed to cross it.